This is after the membranes are fixed or membrane is end capped, let's say. Then what we do is we use again the same technique, similar technique what we have used before for checking the membrane if it is good or not. But this doesn't mean that there is permeance. I'm not talking about the permeance. I'm only still talking about the leakages. If there are any leakages somewhere in the membrane or not, that's it, and nothing else. So for here, the membranes, the end capping procedure will be taught by you by Johan on Monday. I don't know if you already took you to the station. All right. Oh, it was the other people. It was all Adesh and all the other big people over there. So I was there, so I showed them how to do it.
But so what's again we will do now?
This is the very similar procedure or similar thing what we have done with the bare membranes or with the first membranes without the end caps. It's again checking if there are any damages to the membrane after end capping.
Okay.
So this only tells us if there are any damages, because we know the leak flow of already the membrane before. We had an indication how much is the leak flow. Then with the end caps, it should be low, or it should be the same, but it should not be higher than that. If it is higher than that, that means there is a problem somewhere. Yeah?
Understand.
So this is how the membrane looks like after end caps. This is the top end cap, and this is the bottom end cap, which is end, and then there is a flange which is welded. See, this is a weld.
Understand.
And I'll show you with because it's a good idea how the membrane is welded. Then you're already taking the video, then it looks good. So when the membrane is leak tested with this installation, then what we do, okay, it's tested for our first, let's say, first preliminary examination. The membrane is passed. Let's say we say that okay, it's quality control, it's okay. Then what we do, we go for capping the membranes. For capping the membranes, what we do, we have a sort of a holder like this, which has a graphite sealing inside. You see, it's a graphite sealing inside.
Yeah.
What happens is this graphite sealing, when you put some pressure on it, they're going to expand in this direction, in lateral direction. It can't fall down because it's edged
blocked
it's blocked from the bottom. You can see it's blocked from the bottom.
Yeah.
It can't fall down. The only way is when you put pressure on the graphite seal, it will just expand, and it will expand and it will hold the membrane. So what we do, this is how first it goes in. I'll show you this technique, or even Johan will show the technique directly when you go for end cap, but I'm just showing an example. This goes in, and then on top of it there will go some graphite sealings which will be exactly on top of each other. There will be graphite rings, sealings. I'll show you the sealings which I have. So these are the graphite seals. What we do is we take these seals, they'll come on top of the membrane like that. You can take one or two depending on your choice. Normally I take two, but it's already thick. I'll take one. It's on top. Only I'm using this one to have the safety on the membrane on the top side, because if nothing is there, then this is going to break. So I'm giving that cushion effect by a graphite seal on top of, like, because the diameter on the graphite seal is exactly the same. Goes on top of like that, and then first the open end cap goes to the top like that, and then when it's fixed like this, you put some pressure on top of this one. You're squeezing this. You're putting pressure so that it squeezes, and then see this is open end. You can see how much is squeezed, the space. This is the open space. When it gets squeezed, it goes up till almost like this.
So this goes inward.
This goes inward. Yeah. The top one, this one,
Yes.
goes inward till you put the 3 bar max, and then without the pressure, it goes, nothing goes more anymore.
And the graphite is already
inside.
here,
So
and
that is
it will be
expanding and it is
blocked.
holding the membrane.
Okay.
And then you first spot weld 3 places, so that then it is not moving after the spot weld, and then you just complete the welding. That's how it's done, but that will be shown later. That's okay. So put the pressure, graphite is expanding and it's holding the membrane. That's the top one. Bottom one exactly the same way. Squeeze. Same thing. Goes like that. Goes on top of it. Like that. It's fixed. You push the pressure with 3 bar pressure, goes there, then it's fixed. And then you can see the top, how much it squeezes. So this is the starting point.
It almost goes
It
inside.
almost goes in. So that's how much of graphite is just going to squeeze. Yeah. That's how the capping is done, and that's how the membrane is holding in place. So after capping, top and the bottom, this is the open side of the membrane. So after it goes in like this, after it is squeezed in, this one is welded like that. And that's why we get a flange. And that is this one.
Okay.
This is the flange, and this is the dead cap, and this is the open end cap which is attached to the flange, and then you have an opening here. And this is for the permeate flow. This is for the permeate flow, and the radiant flow is on the other side. Yeah? Questions? Okay.
Mean these interactions are just by the graphite helping to make the connections between
Between the membrane and the cap.
because the stainless steel should not exert pressure directly on the
Membrane. Otherwise, it will give some
Otherwise
sort
it
of
will
cracks. Yeah. So after this, after welding is done, because welding is at a very
for
very
each
high
membrane you are doing welding
Now we have to have these caps.
because this is necessary for each membrane, right?
Yeah.
For testing.
For testing. If not, then we cannot test.
You
this
cannot
membrane.
put in the module.
Afterwards, we have to quality test the membrane again because it has seen such a high temperature, because welding goes to almost like 1600 degrees, and the membranes are designed only for 600.
Understood.
So it's such high temperature, so we have to check if the membrane is still good enough. For that, we have to check the same way what we have done before, but in a different sort of system. We made this system where we put in, where's the here. This is sort of a sealing which goes in like that. You can see it's fixed layer, and it has a graphite on top of the sealing here. You can see there are two
Just
rings.
the black ring.
Yeah, just there. There are two things. You can see inside and outside.
Understand.
So it goes in, one goes in. On the flange, it's just going to fix on the top. And then it should go exactly on the outer ring.
Mm.
And then you squeeze it. Like that. Then you fix it. You have to squeeze it nicely, otherwise if you don't do it properly, then it will leak. Because now it's already open there. See? So we have now it's properly fixed. Yeah, it's now nicely fixed. Yeah, in all directions it's fixed and it's tight. Just see, check it once again. Okay, I can't do more. It's fixed. Yeah. And what we do is we use the same setup. But this one goes in
Directly.
So you put this here. connected.
Yep.
Then you connect it directly.
Yeah, because they had this thing with the switch lock. And then for this one, should not move, not to be honest. And then we have to only check this portion because it's all welded and everything. We don't have to do anything there. Only
All is closed.
all is closed. Only because this is the part what we are playing with that might leak. No, just put some pressure in there. Put some flow in there from some few droplets of snoop. Then we're going to check the system. First, always one bar. It's not more than that, so it has to equilibrate. That's quite tight because that's a palladium membrane. I know, and then palladium and nitrogen, they are like it's 100% separation. So to release the pressure will be a lot of work. It won't be leaking because the pressure doesn't fall down.
In this the 1 bar pressure?
Yeah, because you can see that the pressure is not falling down at all. You see?
Yes.
So for me, that looks like a very good membrane. I'm using such high flows, it doesn't really work out. So I just directly shift to what I do is if I have to do it quickly, I just use high flows, and then when it's coming to close to the pressure which I want to have, then immediately I shift to lower flows. Then it's giving low flows, and then okay, then it is fine. It's already too late. Now it has to come down to 3 bar and then equilibrate. That's going to take a really long time.
Really?
But it's a palladium membrane.
So it will hold the pressure inside. This is the, what you call it, this is the property of
Palladium membranes, yes.
Because the nitrogen is, because the size is not compatible, right?
Yeah, hydrogen is
Yeah.
small, but nitrogen molecule is bigger.
Bigger, so it
So it
will
won't come out.
hold it inside.
Yeah. Takes a bit long time